We're asked to find the inverse for the function f. F is going to take whatever you give it, double that thing, and then add 10. And I want to find the function that does the opposite stuff in the opposite order. So my first thought is to take this f of x, replace it with a y, and then recognize that what an inverse does literally is it takes every x that got turned into y and turns it back. So it takes that x and y and it flips it around. So instead of using y equals 2x plus 10, I want x to equal to y plus 10. We're just literally switching x with y. Where we see x, we put y. Where we see y, we put x. And I'm going to solve this thing for y. And if this is the kind of thing that kind of intimidates you or throws you off, I do want you to keep PEMDAS in mind, our old friend, order of operations. And we're going to solve, so we're doing this all in reverse. This is what I'm trying to get to be all by itself. So I'm looking at this, and I'm starting down here at the bottom, and I'm saying, is there anything that needs to be added or subtracted to get that y by itself? I can see a plus 10 here, so I'll start by subtracting 10 to cancel these off. On the left side, these are not like terms, so they make x minus 10 equals 2 times y. I took care of that. I'm now going to go up a step and say, is there anything on this side that needs to be multiplied or divided? I see the 2. I'll divide this side by 2, and I'll divide this entire side by 2. That looks like this. Entire side divided by 2. And I'm going to leave it like that. These are going to cancel, and so we're going to have y equals that entire x minus 10 all divided by 2. We don't really write a lot of expressions like that, but this is like the time where you start to hopefully get comfortable with things that look like this. Now, as a final step, I do want to definitely communicate that this expression here is supposed to have undone what this one did. This one was called f, so I want to call this one f inverse. That's where this little -1 thing comes in. It looks like an exponent, but this is not a number, so this is not an exponent. It just looks like one. This means the inverse of f is equal to x minus 10 over 2. Now, it's like a final step. I can do a quick mental check. And my quick mental check, which I'll do in orange, here's my brain. If I did this all correctly, I just pick a random number, I throw it into f, I see what pops out, and then whatever pops out, I put that into the inverse, and I hopefully get what I started with. So for example, I'm just going to pick like a number like 8. If I take 8 and I throw it into f, f takes what you gave it and doubles it. So if I double 8, 2 times 8 is 16, and then I add 10. So 16 plus 10 is 26. What should happen is this, if I take this 26 and throw it into this inverse, I should get that 8 back. So the inverse f26, the inverse takes what you gave it, subtracts 10 first, so 26 minus 10. 26 minus 10 is 16, and then divides that by 2. 16 divided by 2 is 8. So this isn't like really a proof that I'm definitely correct, but it definitely is a strong indication that I didn't make any dumb mistakes. F turned 8 into 26. F inverse turned 26 back into 8. Pretty sure that I'm correct. There's nothing special about the 8 that I picked. I could have picked any number I wanted. Whatever it got turned into, if I plugged that into the inverse, it would have gotten turned back to where I started. So good luck with this. Yeah, good luck.